The last members of the Zen 5 family are launching today. Well, or wait, tomorrow. The 16-core 9950X3D and the 12-core 9900X3D. They're launching today, tomorrow. For this video, I'll be talking about the 9950X3D exclusively that AMD sent me so that I would have time to play with things. And boy, I have. It beats the Intel 285K quite handily for both gaming and productivity. That's the shocker, isn't it? Productivity? Yeah. But it's because AMD is giving us two of the best chiplets, not just one, as they have in the past with their two chiplet CPUs. It's good. It's really, really good. The reason for the delay? Mostly software QC. Mostly not AMD. Possibly production ramping, but mostly just QC. This is going to be a fun one. I've got more details than I usually do, and it's really interesting. The whole ecosystem, because things have launched. Let's dive in. Zen 5. I mean, Zen 5's got to be old hat at this point, right? It launched last year. What are we still doing talking about it? AMD waited to launch these until the software was fully ready. I mean, sure, we got the 9800X3D gaming dominating champion, but it makes sense to launch these now because, well, AMD was able to watch what Intel came up with for the 285K, and they gave us not one, but two chiplets in each of these CPUs. You see, this time around, we have a V-Cache chiplet and a frequency-optimized chiplet. So this is a departure from what AMD has done in the past. It was V-Cache, and then, you get another chiplet. But now, you get a V-Cache chiplet and the good chiplet from the 9900X, or the 9950X, as the case may be. You've got a good CCD for a higher clock speed, and you've got a good CCD for monstrous 3D V-Cache for gaming. And yeah, it's the best of both worlds because it literally is both worlds. That's the difference. And the secret is efficiently choosing which CPU to run your software on. And guess what? That's also a solved problem. And that's why it's so important to have the right BIOS and the right BIOS settings and the right chipset drivers to take advantage of the chiplets. Drivers installed on Windows. If you're on Linux, check out our Day 1 Linux review. Linux already has and has had what you need for quite a long time. But let's get right to the benchmarks, starting with Geekbench 6. This right here, this is the whole review in a nutshell. 3474 single thread, 23766 multi-core. This beats the Intel Core Ultra 285K to Core Ultra 9, and yeah, this even beats the 9950X. What the heck? It's beating the 9950X. Well, keep in mind the 9950X has one frequency optimized CCD and then one low power CCD, so it's about 2,000 points slower than the 9950X 3D in multi-core. But it's also about 1,500 points slower than the 285K. So the 285K came out a little ahead here on multi-core because it's 24 cores. But a mild overclock on the 9950X, sure, that'll put it ahead of the 285K. But our X3D numbers right here, right out of the box. Boom, look at that. No waffling about it. Best CPU ever. And yeah, 285K, not doing quite as well. And that's going to be the pattern for this entire review. CPU-Z flirting with 900 points on the single thread, and you can get over 900 with just a 25 megahertz overclock, which was attainable on the CPU that I have. Cinebench R23, wow, look at this stack up, 2282 and 44314. Goodness gracious me. What about Cinebench R24? Also strong, 2537 and 142. Now notice our MP ratio here is greater than the number of cores. This is a workload that has better than perfect scaling, owing to the giant shared cache helping speed things along because rendering. You get a little bit of an overlap. There's a little bit more of an uplift, more than just the number of processors. What about artificial benchmarks, like our 3D Mark CPU profile? Okay, some of the artificial benchmarks here are going to have the Intel 285K pulling ahead. But I think this was only true in artificial benchmarks or in situations where I sort of understood what was going on and things were weird. Firestrike is off to a strong start, but Time Spy is a bit of a head scratcher. What is going on? The 12 cores are faster than the 16 cores? I'll let this result in, but the problem here is one of scheduling. Time Spy does its own core scheduling. And it's great on the 12 core. It's great on the 7900X 3D, but bad on the 7950X 3D, and by extension, bad on the 9950X 3D. This is some of the same kinds of things that we see in some games like Far Cry 6, where it will try to, be self-determining for what it should do, and it just doesn't do it very well, and it needs to be overridden. In this case, we're not overriding Time Spy. Hilariously, this benchmark on Linux, literally the same software meant for Windows, but running under Linux with Proton and the magic of that, yeah, it performs fine in this same scenario. Like, it'll score really high, like the highest on the chart, which tells you it's not the hardware that we're dealing with here, it's probably the operating system. So let's get into some games. Now, I ran through tests with the 4090 Founders Edition and the 5090 Founders Edition we have here in our test bench based around the X870E Aorus Master, and there are results that I thought were really interesting. This isn't all of the results because I don't want to be here for 5 hours, but these are the games that I enjoy, and these are the ones that I thought we could talk about the different kinds of patterns. Starting with Ashes of the Benchmark. 68 FPS. Now, while the Core Ultra 285K and the 9950X were neck and neck with a slight edge actually going to the 285K, the X3D pulls ahead here because that's what this benchmark has been known for since time immemorial. No surprises here, really. Cyberpunk with the 4090 at 259 FPS to 1080p. Now, the 5090 here was not as interesting because the 5090 1080p performance does not generally scale like you'd think that it should. The 5090 is really it's a much faster card, but it's not really faster for 1080p a lot of the time. It doesn't enable 300 FPS at 1080p in Cyberpunk. You want 259 FPS at 1440p. Now that is where the 5090 will help you. So it's gonna be a recurring theme. We'll talk more about that. Dragon Age. Our best results here were from the 5090, not the 4090, so that's what I've got here. But every resolution here, the X3D is pulling well ahead of the 285K, even 4K. It's an interesting result, I think. What about with ray tracing? Also, kind of a surprise, but it kind of makes sense a little bit if you think about it. Good Lord, what a performance gap at 1080p. Look at that. Final Fantasy Dawntrail. This is a great game. This is actually a lot of fun to play. And this is a game that will do weird stuff like in the middle of the game. So this is a fun one to actually benchmark. Now, if you make a big deal about the AMD thing, the AMD dip, the Core Ultra 285K is the poster child of that kind of performance glitch anomaly stuttering. I was able to make that go away, setting the power plan on the Core Ultra to performance, not balanced. But for AMD CPUs, balanced is the recommended power profile, and it's the one that you want almost all of the time. And that makes sense. We'll talk more about that in a second. Callisto Protocol. Well, with the 5090, there really isn't a functional difference between 1080p, 1440p, and really even 4K, at least if you're running the 5090. Have I mentioned how these 240 hertz OLED monitors, they're like butter for your eyes. They're so good. They're so fast, so low latency. And finally, Shadow of the Tomb Raider. Well, not really finally, almost finally. We've got some others to talk about. Just to really drive home the point that for the 5090, 1080p and 1440p are functionally identical performance because, well, I mean, it doesn't, maybe they'll fix that with a driver or something, but the 9950X 3D is insane here. And the performance difference between it and the Core Ultra 285K is just bananas. Goodness. Now, other games, other fun indie gems, Stellaris and Factorio to start. Well, for Stellaris, the Stellaris benchmark is it's loading one of my giant games and running through and checking a whole bunch of stuff. How long does it take to go through a year? 40 seconds. So that's really good. This is actually about a 9.3 to 9.5% performance improvement over the 7950X 3D. And yeah, so that's pretty amazing. 3D V-Cache processors are a world-class experience with Stellaris. And Stellaris has improved. I mean, to be sure, the game runs a lot better than it did a year ago in terms of complicated stuff going on, late game, that sort of stuff. This save file is not actually all that complicated, really, but it performs consistently across a whole bunch of different machines, and the performance can range anywhere from like over a minute to 40 seconds as we have here. Now, Factorio, the benchmark is not benchmarking what you think, but the benchmark loves 3D V-Cache. And the performance is basically identical to a 9800X 3D, but I did have to explicitly toggle game mode via the game bar. Otherwise, Factorio was running on the fast CCD instead of the V-Cache CCD. Factorio needs to run on the V-Cache CCD. But once it was running there, yeah, we're getting 485, 490, 495 updates per second, which is right in line with the 9800X 3D. We'll take a quick look at Blender. Blender is useful because it's a rendering program that we can just let run for hours and hours and hours and make sure that nothing bad happens, that the system is stable, and that everything works really well. Sustained workload. Our Aorus platform and our plucky, modest little Cooler Master 240mm AIO did fantastic here. No complaints. No fires, nothing going to burn down. It's great, fantastic. PugetBench also looks really good here for our system overall performance. Our system configuration was with the G.Skill 2836-3696 CR1 memory. Having a kit with these sorts of timings is pretty important for getting the absolute maximum performance. As you can see from our 8064, 70.8 nanoseconds memory latency. As reported by 8064, yes, 8064, take those numbers with a little bit of a grain of salt. It's not a perfect program for doing this. With manual tuning, I could achieve 63 nanoseconds as reported by 8064. Definitely worth your time to do that. But I mentioned all this because I also picked up a CL26 memory kit from G.Skill, but the performance of that kit was not better than the CL28 kit. And oftentimes, getting the board to post without training issues at CL26 was a little problematic. So I'm working on a separate video for that. I'm hoping that CL26 with a latency like 63 nanoseconds would be something incredible. But for right now, I'm just telling you CL28 because those kits are cheaper and it'll get the job done, and DDR5 6000 is the sweet spot. And for some of these games, especially with a higher end GPU, it does make a bigger difference than you would think. And that will also factor into some of the AMD dip stuff before. So another note on game benchmarking. I mean, usually that kind of ties in with all that. Usually when you want to be in a CPU limited gaming scenario, and usually that means 1080p. And we just had a new GPU launch. And so you would think, yes, this is the card for doing 500 FPS at 1080p with the 5090. The problem is the 5090 performance does not scale the way that you would think that it should. 1080p performance is not linearly related to 1440p performances related to 4K performance. And that's probably because of bottlenecks elsewhere. And this is like, okay, so AMD's flagship, the 7900 XTX, it doesn't do you any favors either when you are looking at CPU performance at 1080p or even less. The performance between the 9950X3D and the 7950X3D in games is really close when you're using a 7900 XTX, and that's because even when the GPU isn't necessarily the bottleneck, there are other bottlenecks elsewhere. So it's something to keep in mind. I also spend a lot of time doing real world gaming testing, like actually playing the games, because there is something to the reports from gamers about, the AMD dip or, whatever, but the source of that is not mysterious. Most of the time, it comes from scenarios where the system is not fully loaded and that balanced performance profile is putting something to sleep. Something may go into a lower power state. For example, the NVMe link, the NVMe from the drive to the system could drop down to a lower performance, just as the game needs to load a texture, and then the NVMe has to wake up again, or that part of the level needs to be loaded. And that can cause a frame dip or a stutter or something like that. Another kind of thing that's related to that is memory pressure, where something was cached in memory, but then it was evicted. Or sometimes you run a benchmark where the game asset was pre-cached or cached in memory, but another benchmark where it was not actually cached in memory, like the first time that you've run a game on a clean boot. And so those things will contribute to things that have been identified as being, it's like, oh, this platform performs differently, when the reality is that that's not actually true. It's really down to, is this the second or third or fourth run of this benchmark? Is it the third pass in this because whatever was cached in memory? Do the systems have the same amount of memory? If you have a 64 or 96 gigabyte configuration with 2 DIMMs, then more of the game can just hang out in memory, and you will experience better 1% lows as a result of that. AMD's chipset driver has become aware of some of these kinds of edge cases. They really put a lot of work into that. That's where I'm going with that. And so while the chipset drivers doesn't handle every single edge case, like if you're got a lot of memory pressure, it's not going to be able to help you deal with that. But it does help you deal with a lot of stuff like that. Let's take a look at Far Cry 6. Our 1% lows And our frame rate, our 1% lows are 10% higher, and our frame rate is 3% higher when core parking is working correctly. And we can see in Task Manager that the individual core graphs keep the gaming workload on the V-Cache CCD, and the high clock speed CCD is mostly idle when we run through the Far Cry 6 built-in benchmark during the run. If you have other stuff going on in the background or something is not working correctly and that doesn't do that, then Far Cry is bouncing between CCDs, and the bounce between CCDs has a performance penalty. Windows 24 H2 also improves this kind of behavior because the Core Ultra 2 processors now face the same kinds of optimization constraints and problems, the same challenges that AMD has had for a couple of generations. And as a result of that, it seems to me that Microsoft has really put a lot of work into optimizing Windows 24 H2. In fact, since the Intel Core Ultra launch, Intel has made significant performance improvements to their platform, and there are also significant performance updates to Windows and Windows 24 H2. And as a result of that, both AMD and Intel have enjoyed significant performance uplift. I'm talking greater than 5% in some of these gaming scenarios where it's a little bit of an edge case. And so all of this, consternation around platform updates has actually benefited AMD and Intel almost equally when we're talking about the operating system. Intel's got a few extra performance bumps in their BIOS updates and their platform updates, but AMD's been sitting here doing optimizations as well. So the 9950X3D beats the Core Ultra 2 285K in just about every gaming scenario and productivity scenario, which is amazing. AMD's got the fastest, no compromises desktop CPU that you can get for any desktop workload now as a result of good hardware and optimizations. So congratulations, AMD. Where do you go from here? I'm hoping it's 32 cores and a crap ton more memory bandwidth. 32 cores in the mainstream, that'll be a lot of fun, and that'll be really exciting. Are there any real downsides with the 9950X3D? If you look at the price, you might say, oh, it's a little high, but it's really not. The price isn't really even a downside because I can run this CPU in a really inexpensive AM5 motherboard. And one of the great things about the AMD design thing is that the motherboard maker has done it wrong if the CPU doesn't perform as well in a less expensive motherboard, which is, you can't say the same for the competing team. The Intel platform does have much more memory bandwidth, but AMD's still winning on memory latency. So AMD's got a lower overall power and lower overall memory latency, even on their non-V-Cache parts. But that's about all I can come up with as a downside. It's like I don't have quite as much memory bandwidth. That's a really, 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 really small nitpick. That's basically nothing. So yeah, if you're looking to build a no compromises gaming machine, the 9950X3D is basically an unstoppable monster that does everything. And if you run into problems, chances are it's scheduling related. And you should also check out our Linux channel video, because testing the specific scenarios in this video where something didn't perform as it should, recreating that exact scenario on Linux, looking at you, Far Cry 6, and artificial benchmarks, and a couple other things. It worked fine in Linux. There was no problems in Linux. So in Windows, it's like, okay, we can just do what we need to do in Windows. Oh, look, Far Cry 6 is now just running on the V-Cache CPU. Oh, everything's fine. Or Factorio is running only on the V-Cache CPUs. Oh, everything's fine. Yeah, it's great. I'm Wendell, this is Level 1. This has been a quick run through of the fun stuff that I found with this, and hope you check that out. Check out the Linux review. I'm signing out, and I'll see you in the forum. In case I missed anything or whatever, let's do some builds. Let's do some other motherboard configurations. You don't need the most expensive X870E. You can totally run this on a potato class motherboard and save hundreds of dollars. Anyway, I'm signing out, and I'll see you there.